Alright, today's video is going to be putting everything from the last few days together. We've talked about 4 different kind of conic sections: circles, ellipses, hyperbolas, and parabolas. We're going to start each of the problems together, and then you're going to finish them and check your answers. So it's a little bit different format than what we're used to for our videos. So with that being said, I want to make sure that you have your circle notes out, your ellipse notes out, your hyperbola notes out, and your parabola notes out. If you don't have them out, go ahead and press pause and get them out. So we're going to start by writing the equation in graphing form and determining what kind of conic section it is. And these two go together. You don't necessarily have to put it in graphing form before you know what kind of conic it is. We look at our first equation. We've got 3x squared plus 3y squared equals 27. We know our options are circle, ellipse, hyperbola, and parabola. The easiest one to determine is parabola, because in a parabola, either the x is squared, or the y is squared. Only one of your variables is squared, not both of them. With circle, ellipse, and a hyperbola, you're going to have both the x squared and the y squared. Hyperbola is the next easiest one to recognize, because in a hyperbola, you are going to have one of your pieces being negative. So either the x squared or the y squared. One will be negative. With a circle and ellipse, you have both the x and the y squared, and they both are positive. The only difference between a circle and ellipse is in a circle, all radii are congruent, and in an ellipse you're going to have an r of x and an r of y. You're going to be going different directions, or different amounts in the x direction and the y direction. So again, the only difference between the circle and ellipse is in a circle you're going the same distance all the way around. In an ellipse you go a different distance in the x direction than you do in the y direction. So when we look at our first equation, we have to determine what kind of equation this is. Some of you may be thinking it's an ellipse, but it's really not, because the 3 and 3, because they're the same, that's the same distance. We have the same distance for our x and our y, which makes it a circle. But we know that when we have our circle equation, we don't have any numbers with the x and the y, so we've got to divide that out to get x squared plus y squared is equal to 9. So what I want you to do, using your circle notes, and hopefully this one's not too hard, I want you to give me all of the important information and graph your circle. Alright, let's see how you did. There was no movement with the x or the y, so our center's at 0, 0. 9 squared, or 9 is set equal to our c squared, so our radius is not 9, but 3. So we start at 0, 0, we go 3, right, left, up, down, and there is our graph of our circle. Moving on to our second example. And we look at our second example, the first thing that catches my eye is that inequality sign. I can have an inequality sign for a circle or an ellipse. I would not have them for our class. We're not going to have them for hyperbolas or for parabolas for this chapter. Okay, so if I know that, I know it's going to be a circle or an ellipse. I see that I have x squareds and y squared, so it's not going to be a hyperbola. And I know that I have both of them squared, so it's not going to be a parabola. I know that this one is going to be an ellipse, because the number with the x squared and the y squared are different. That means my r of x and my r of y is going to be different. So now that we know it's going to be an ellipse, I want you to go ahead, bring out your ellipse notes, and I want you to take the equation, put it in graphing form, give me all of the important information, and graph it. Alright, so go ahead and press pause. Okay, we start by completing the square to get our equation in graphing form. With an ellipse, we always have it set equal to 1. This time it's an inequality, so it's greater than 1. We've got to make sure that once we find what number's underneath the fraction, we take that 25 and we actually put it underneath so that we have our r of x as 5 and not 25. So we start by finding our center, -4 positive 3. Our r of x is 5. Our r of y is 2. Since 5 is larger, that's going to be the major axis, and since 2 is smaller, that's the minor. When we are finding the c value for ellipses, we subtract the major squared minus the minor squared, and we get that that's about 4.6. For ellipses, the foci are going to fall on the major axis. So since r of x is the major, I'm going to count over 4.6 from the vertex, from that center point, not the vertex, the center. So since we are moving left and right, we take that x coordinate, the negative 4, and we add 4.6, and that's how we get 0.6 up 3. The y coordinate of the center is not changing. Then we have to move left, so we've got a negative 4 minus that distance from the center, and we get a negative 8.6. Because we had a greater than symbol when we went to graph, we had to have a dashed line for our ellipse. Always use your test point. I would use my test point of 0, 0. So when I look at my original equation, 0 in for x squared, that's gone, that's gone, that's gone, that's gone. Is 0 greater than negative 189? Yes, that is true. So therefore, I'm going to shade gray true there where 0, 0 is. So everything inside of the ellipse is not going to be shaded for this problem. All right, turn your sheet over. We've got more to go. All right, we look at our equation. When we look through the equation, we see that we have the x squared and we have a y squared. Since both of them are being squared, we know it cannot be a parabola. Then I look a little bit closer at the squared pieces, and one is positive, one is negative. The only way we can have one positive, one negative is if we have a hyperbola. So when you see this on a quiz or test, you do not have to complete the square when you're trying to determine what kind of conic section it is. You can look at the equation in standard form and determine it. So now that we know it's a hyperbola, at this point you should have your hyperbola notes in front of you, and I want you to go ahead and put this in graphing form and give me all of the important information that you need for this one. Okay, let's see how you did with the hyperbolas. Again, we start by completing the square. Make sure that when you pull the negative 25 out of the y term, you pull the negative out of the negative 200, so that's becoming a positive 8y. If you don't get the correct equation in graphing form, make sure you're going through every step and finding out where you made your mistake. You don't want to keep making that same mistake over and over again. So once we have our equation in graphing form, we can find our center, which is at 2, negative 4, opposite of what we see on the inside. Our r of x is 5, our r of y is 3. When we are finding our c value, we are adding the squares together. So 5 squared plus 3 squared gives us 34, but that's c squared, so we take the square root, and that's about 5.8. When we have our box set up here, center, there's our r of x, our r of y. We've got dashed lines because it's not really part of our graph. Our vertices are always going to go on the positive axis, so we go back to the equation in graphing form, not in standard form. You don't go back here because it could change. So once the equation's in graphing form, we have that x is the positive axis. Therefore, our vertices are going to be those points on the box that were on the x. So our vertice number 1 is 7, negative 4. Our vertice number 2 is a negative 3, negative 4. The foci are going to go on the same axes as the vertices. So we use that c value of 5.8. Since they're on the x-axis, the foci are moving left and right, which means that the x-coordinate of the center is going to change. So from the center, from 2, we are going to go right 5.8 because that's the c value. So 2 plus 5.8 gives us that 7.8, and then our y did not change, so it's still at negative 4. Then we subtract 5.8, and we get a negative 3.8. Make sure that when you're graphing your parabola that your vertice is being used in the graph and not the foci. The foci are inside of the graph itself. And the last piece of important information that you need for parabola or for hyperbolas is the equation of those asymptotes. Those asymptotes is what gives your graph its shape. You always use the center point, which is at 2, -4, and the slope, we're going up 3, right 5, which can be found from the r of x and the r of y. You can go ahead and stop in point slope form, or you could continue and put it in slope intercept form. The only difference between your two asymptotes is one is going to have a positive 3.5 slope and one's going to have a negative 3.5 slope. So we have our second equation there at a negative 3/5. Okay, we only have one more left. And x plus 10 is equal to a negative 2y squared plus 12y. Well, in this equation, I see that only my y is being squared. If only my y is being squared and not both of them, I know it has to be a parabola. And when I look at this, I see that the y is being squared. So it's going to be an x equals, which means I'm going to have a sideways parabola. All right, at this point, you know the drill. Go ahead and press pause. And then I want you to go ahead and look through your parabola notes and make sure that you're looking at the sideways parabola notes. Put it in graphing form and give me all the important info. Alright, on our last sideways parabola, again we start by completing the square. Completing the square is always what you're going to use to put it in graphing form. If you don't have the correct graphing form, go back through and check all of your steps. The vertex, we have a center for a circle, a center for an ellipse, and a center for hyperbola. For parabolas, we have vertex. And we have our x and our y. Since this is sideways, the y is on the inside, so that negative 3 is a positive 3 out there, and the outside number is the x. So be careful that you didn't switch those two numbers. Since we have a sideways parabola, that axis of symmetry, that line cutting our parabola in half is going to be a horizontal line, so y equals 3. X-intercept, if we want the x-intercept, that is when y is equal to 0. If I look back at my equation standard form, if I plug 0 in for y, that's gone, and I get that x is just left with the negative 10. For your y-intercept, it's not as easy. We are plugging 0 in for x, and I would do this in the graphing form, so I would plug it into this equation right here, and I move the 8 over, I divide out the negative 2, to get to the y minus 3, I square root each side. 3 plus 2 gives us 0, 5. 3 minus 2 gives us our 0, 1. So I would start graphing at this point. We have our vertex at 8, 3. Our axis of symmetry, that horizontal line going through. We have an x-intercept at negative 10, 0. And we have our y-intercept at 0, 5 and 0, 1. That will be our shape of our parabola. Since it's a2, which is greater than 1, that is narrow. Since it is negative, I know that it's going to be opening to the left, which it is. Now for our p-value, that distance from the vertex is 1 over 4a, and the a is negative 2, so that gives us a negative 1/8. The focus is the point inside of the parabola. So if this is my vertex, I'm going to go inside the parabola, so I'm going to go left. So I'm going to subtract 1/8 from the x-coordinate of the vertex. Since I'm moving left and right, you look at the x-coordinate, and I get that my focus is at 7 7/8, comma 0, or you could have it as an improper fraction of 63 over 8, comma 3. Did I say comma 0? That should be a comma 3 for the first one. And the directrix is going to be outside, so we're going to the right, so we're adding 1/8. That is a vertical line, so that is x equals 8 1/8, or x equals 65 over 8. So every different conic section has a little bit different rules, and it has a little bit different information that you have to give. So you want to make sure that you're really clear on what makes an equation a circle, a hyperbola, an ellipse, a parabola, and know the information that goes with it and how to find that information. I'm not going to tell you how to find it on a quiz or test, so you've got to make sure you've got to know what to do given the situation. All right, and that's it.